Now let's see the difference between the mirrors and the lenses. This is a convex mirror, this is a concave mirror, and this is a convex lens, and this is a concave lens. Okay, so these are mirrors and these are the lenses. Now let's see the difference between them. Now a mirror is opaque, it's not transparent. The rays of light cannot pass through this. Okay, the rays of light will be reflected. They cannot pass through this because it is opaque. Whereas lenses are transparent. The rays of light can surely pass through them and reach the other side. Okay, that's the first difference. This is opaque. The mirrors are opaque, whereas the lenses are transparent. Now the next difference is the mirrors will reflect the ray of light. Okay, it will fall on the surface, the incident ray, and it will get reflected. In both the convex as well as concave, they reflect the ray of light falling on them. Whereas here, as they can pass through them, they are not getting reflected, but they are getting refracted. And we know what is refraction, the bending of the ray of light when passes through one medium to the other. So here they refract. Mirrors reflect, whereas the lenses refract the ray of light. Now the third difference is the center of the reflecting surface of the mirror is called the pole. Okay, here you have the pole marked with capital P, and we know that a ray of light which passes through P, through the pole, is reflected in the same direction without any deviation. Same way for the lenses, it's not pole. The center of the refracting surface is called as optical center. It's marked as O. It's O, optical center. So a ray of light passing through O will come out without any refraction, without any deviation. It will pass straight through this. Now the next difference will be, this is your convex mirror, and it is also called converging mirror. Diverging mirror, because you can see the rays of light are getting diverged. Whereas if you, at the same time, if you see the convex lens, this is convex mirror, it's called diverging mirror. This is convex lens. The rays of light after refraction, they meet. So it is converging. It's a converging lens. Convex mirror is diverging mirror, and convex lens is converging lens. They converge. And here, this is a concave mirror. The rays of light after reflection, they meet at a point. That means they converge. So they are converging mirrors. Whereas if you go for the concave lens, the rays of light after refraction, it emerges out. That is, they are diverging lenses. Now for the ray diagram for the mirror, which we have already done in the last class, we had the center of curvature, the principal focus, and the pole. So we started from here, 2 cm, C to F 2 cm, F to P 2 cm, and keeping the compass at C and CP as the radius, we draw this arc, and this is M and N. Okay, so you have C, F and P. But for the lenses, if you start from here at C, from C 2 cm at 2 cm F, and from F the center O, then another F this side, and C. That is, you draw a straight line first, and then keeping your compass at C, you take 2 cm and mark this point, then F to O, another 2 cm, then 2 cm. So total you have 1, 2, 3, 4, 5 points. Whereas for the mirror you had only 3 points. Now here both the sides. Now we know that this is principal focus, and this is the center of curvature, and this is the optical center. Since this is on the same side of the lens, we mark it as f1, and we know that the center of curvature is twice the focal length, okay, or the radius of curvature is twice the focal length. R is equal to 2f. So instead of C, we will mark this as 2f1. Okay, this is f1 and this is 2f1. Actually it is C, so no need to write C. We'll consider this as 2f1. So if this is f1, this one will be f2, and the C will be 2f2. Okay, and then with the scale you will have to draw one perpendicular to this principal axis. You draw one perpendicular dotted line, and that will be our main surface for the refraction of light. The ray of light will pass through this and it will get refracted from this. Okay, now we know we need to draw the lens. For that, we can take 2f2 as the center and O little further from O, or whatever height you want for the lens, whatever size you want, you can keep the point there. Okay, your pointer here and pencil here, and draw the arc. And with the same measure, you have to keep it at 2f1 and draw that arc. So your lens is ready. Or you can even draw this lens freehand, because the point of refraction or the line of refraction will be this dotted line. We are going to consider this, not this. So this is our first diagram when the object is kept at infinity. Okay, the object is far away, it's at infinity. Now the rays of light parallel to principal axis, this is center one is your principal axis. So the rays of light parallel to principal axis, after refraction they will meet at f2. Okay, so the image will be formed here. Now where is the image formed? Image is formed at f2. Where was the object? At infinity. Image is formed at f2. Now what is the nature of the image? It is, if the image is formed on the other side, it's called real image. Okay, it is opposite to mirror. In mirror, if the image is formed on the same side in front of the mirror, it was called real. Whereas in case of a lens, because it is transparent, the rays of light has to pass through the lens. So the real image is formed on the other side of the lens. So it's real, and real images are always inverted, and the size is point sized. And that is what you see in your textbook. Position of the object at infinity. The object is at infinity, far away. Position of the image is at f2. The image is formed at f2. Now what is the size? Highly diminished, point sized. Highly diminished, it's point sized. And the nature of the image, it's real and inverted. Now let us draw the second position from the table. You have an object beyond 2f1. Okay, this is your f1, this 2f1. The object is beyond 2f1. Let the object be AB. Okay, so the first ray will be a ray of light parallel to principal axis. This is your principal axis. A ray of light parallel to principal axis. After refraction, it will pass through F. Okay, this is F. That is F2. So ray of light parallel to principal axis. After refraction, it will pass through the principal focus. So let's draw that. So here it is, a ray of light which is parallel to principal axis. After refraction through a lens, it is passing through the principal focus on the other side. Now the second ray could be a ray something opposite to this one, parallel to principal axis, after refraction passing through principal focus. Now opposite, a ray of light passing through principal focus. This is the principal focus, passing through principal focus. After refraction, it will travel parallel to principal axis. It will meet here. Or a ray of light which is passing through O, that is optical center. It comes out without any deviation. Whether you draw this one or you draw the other one passing through F parallel to a principal axis, they both will meet at the same point. So to get the image, you require any two rays. So I find this one easier, so I've drawn this passing through optical center. It comes out without any deviation, it goes straight, so it will meet here. So the image will be formed here, so you'll have to draw the image here. So this is your image, A bar, B bar. Okay, now let's compare. The position of the object is beyond 2f1, the position of the image between f2 and 2f2. Okay, that's the position of the image. Now what is the size of the image? See this size, now this is smaller, so diminished. And what is the nature of the image? Because the image is formed on the other side, it is called real. And real images are always inverted, so you can see this is upside down. So the nature is, it is real and inverted. Now let's check that in the textbook. So it's beyond 2f1, the image is formed between f2 and 2f2, it is diminished, real and inverted.